Sorry?
You asked the difference between ERGP and the RIP.
Yes, I think.
According to what you taught, I think RIP is for small enterprise. It's like for small organization. But ERGP is the biggest one. It's like for example, if 3 branches or 4 branches, because it is associated with 3 or more routers.
Okay. Very good.
Yes. And the number of hosting IPs is for ERGP is bigger compared to RIP.
Good. I think you are studying. It's good to know that. Anyhow, okay. So now I'm live, guys. If anybody is unable to log in, you can tell to your friends to go YouTube in our channel so they can watch this training. I'm live now in your YouTube. Okay. So let's start these, guys. So let me explain like what is the OSPF. OSPF stands for, guys. OSPF stands for what? Malice, can you tell me?
It's open shortest path first.
Very good. Open shortest path first. Okay. Okay, so as you can see on your screen, you can able to see my screen, right?
Yes, we can.
Yeah. So let me open the slides. Okay, guys, first understand your OSPF, what we are going to discuss now, okay, is very important protocol. The most of the organizations, they use this your OSPF. Open shortest path first. And this protocol, we'll call it as your link state routing protocol, OSPF. Guys, please pay attention. Okay. Before I could this and explain, let me write it down the agenda. What are the things, guys? I told you that please, I want to do a lot of labs today. Okay, I'm going to start with the OSPF. Very big protocol, guys. The OSPF lab. Okay, in that we'll be having a single area lab, and we will do also multi-area. We shall discuss that. Okay, so then we'll also discuss OSPF LSA types. Okay, this is as per the Cisco, they have changed it because previously, so when I learned, okay, there was only single area OSPF configuration, guys. So in your CCNA, when I studied, I think 640.801 exam code. Okay, now exam code changed to 200.301. Okay, they added multi-area now. So you people are very lucky. You are learning OSPF multi-area as well. Okay, LSA type also it was not there because LSA type I studied in my CCNP when I have done the certifications. We have a lot of LSA types. Okay, 1, 2 will be having like 7 LSA types. We shall discuss all these 6. Okay, and LSA lab also we will do today itself. Okay, again I want to discuss yesterday's pendings lab, that is MD5 authentication. MD5 authentication. Okay, MD5 can be configured in OSPF and EAGRP. Okay, guys. Lot of lab, guys. So we have to pay attention. As I told you that. So yesterday's file also I'll share you. Some people they have not received it. That also I'll share you. This is I think yesterday I told you, right? This is the entire your CCNA topology, guys. We are also discussing wireless, your WAN technology, ACL, access control list, and BGP is not there, guys, for you. BGP is for the CCNP. Wireless also we are going to discuss, okay, and redistribution. If possible, if you have time, is up to you guys. If you want to sit for the long time, I'm ready to start today itself your redistribution. Okay, so before I start the LSA lab, okay, so I want to teach you the redistribution. Okay, I hope it's clear now. Okay, now, so OSPF, guys, let's remember. It is a link state protocol. OSPF is your link state routing protocol. Okay, distance vector is which routing protocol, guys? Distance vector.
RIP.
Then RIP and only RIP. Yeah, because just I'm checking now. Just 1 second. Only RIP or what? EIGRP also, right? RIP and your EIGRP also come under your distance vector routing protocol. Okay, your EIGRP is advanced distance vector protocol. Is your advanced distance vector protocol is your EIGRP. Okay, how does it going to work now? So distance vector, what it does means the router by rumor, periodical update. Okay, your distance vector means, yeah. Yes, Malice?
I think EIGRP is hybrid, sir.
Yeah, EIGRP is hybrid. Combination
IGRP, I think. IGRP.
IGRP. That is a word, man. We are not going to discuss IGRP.
Yeah, that's the link state, I think.
No. This is also a distance vector. Link state is only OSPF.
But EIGRP is hybrid, sir.
Hybrid protocol.
Yes.
Yeah, is hybrid protocol. We'll also call the advanced distance vector routing protocol for EIGRP. Okay. So how does distance vector works? Is going to router by rumor means we are going to authorize your network. Correct. We are going to authorize your network. So periodical update. Right. It will periodically update the listing. Whereas a link state and hybrid, okay, a routing table topology, incremental update. So you keep on incrementing the update, you changing its routing table. When any network changes, okay, say example, if you add one more network here, okay, and everybody they update by their routing table. It will send the one incremental value. So it keep on incrementing by updating by their routing tables. If you check, okay, what is difference between your link state protocol and this thing, okay, we can see. So we can see right here. So your distance vector protocol update frequently, update or event trigger. What does it mean, guys?
Sir, you display at least you can minimize to see the whole slide.
Sorry?
The screen sharing.
Okay.
You can minimize so that you can see the whole slide.
Host ID.
Yes.
You want to make the big like this?
Yeah, to be better.
Okay. Okay, no problem, because actually I want to show you the topology which we did yesterday. So I think yesterday we have done some EHRP lab, right? So this is a lab what we did yesterday. Okay, no problem. So what does it mean, guys? What is trying to explain here? What is this update frequently? Okay, what is event trigger? What does it mean?
I think from my understanding,
Yeah.
update frequent, it means, as we told us yesterday, that every 5 seconds it goes and check.
Yes.
In link state, it means when the route that has been added is the one that will trigger the event so that I'm added to the network.
Perfect, Andrew. Very good, man. Very good, very good. See what he's trying to explain here. Okay. See, right now, yesterday we added this topology, right? We added this router. Okay. If you talk about the EHRP, what will happen? Okay, it will update. It's trying to frequently update it. Okay, whereas in OSPF, if any changes in the topology, then only it will increment. Otherwise, no. Okay, every 2 seconds, every 5 seconds, right? Every 5 seconds, it keep on sending both the sides, either this side or that side. Okay, means they are requesting any update from your side, please give me. Okay, if any update available here, then only it will share you. Say example, in this scenario, okay, now, example, we have not added this router. Okay, I'm talking about the EHRP. Okay, frequently update. Okay, it will send every 5 seconds. Okay, if any update has been happened when you add it here, then only it will send. Otherwise, no. Okay, now in OSPF, that is a link state, what happened? Okay, if any changes, then only it will give the update. Got it? If any changes in the network, okay, I have got the new network connected to me, please take this update. Got it, guys?
Yes.
Yeah.
Yes, yes.
That is the difference. Now, so let's say each router is aware of each other. Each router, so as we can see, let me write the text pen. So each router is aware of these things, aware of only of its immediate neighbor. What does it mean? Only the immediate neighbor he can give the update, not for others. So whereas in link state, each router is aware of all the other router in the area. As I told you that it will work based on the area wise. Say example, guys, I think you might know. Okay, so every cities, they will be having the pin code number. Okay, in the each pin code number, they will having a lot of houses, street numbers, house numbers, right? Same thing, OSPF is going to work based on the area number, because as you know that, okay, OSPF, there is no hop count. The hop count is unlimited here. Slow convergence, okay, whereas this is the fast convergence. So proven by router looping, less subject to your routing loops. Okay, looping is very less in the link state, easy to configure, more difficult to configure the OSPF. Okay, that's the reason I told you just pay attention when you do this lab. Okay, OSPF, but it takes time. Once if you practice, I'm sure I think you can able to do it. Okay, and this one, what talking about favor routing source required, more routing resource required. Use update required more bandwidth, update require less bandwidth. Okay, you know, update, if any changes in the network, okay, what is going to do? So the link state, it takes very less bandwidth, and whereas a distance vector, it takes more bandwidth. It doesn't understand the topology network, and this has the detailed knowledge of the distance network and routers, a link state. because as you know that it has been divided as per your area wise. As I told you that it's work based on your area. Okay, the link state. So link state has got the example that is your OSPF and ISIS. So intermediate system and intermediate system. This is one of the protocol. Some companies they are using, guys. OSPF used by the corporate network, guys. Remember, ISIS is used by for especially it is used for the your ISP. Okay. OSPF stands for Open Shortest Path First. Okay, this is one protocol, guys. So as we can see, okay, OSPF is an open standard routing protocol. Okay, open standard means OSPF can be configured in your all different vendor, not only Cisco, even the other devices like Geneva, Huawei, any different vendor available for the router. We can configure your OSPF. It is a free of cost. Okay, it works using by your Dijkstra algorithm. Okay, this is the guy so who introduced this OSPF. OSPF provides the following features: minimize the routing update traffic. Okay, allow scalability. Okay, because EAGRP is limited for your 15 hop, right? OSPF is going to work only on the 15 hop. Okay, whereas EAGRP is going to work how many? 255. That is your EAGRP. Correct. And
here unlimited.
And here this is unlimited.
Yeah.
That's the reason. So most of the organization they use ISP because network has become very vast nowadays, guys. So even at my office, you can see. So here we are using, I think, 4 routers. Okay, on 2 servers and switches. Even I'm using HP switches, HP switch. HP layer 2 switch I'm using it. Okay, it also supports what? VLSM and CADR. Means it's going to support your subnets. Okay, in your network, a lot of network users. So that subnet also they can able to communicate with your other network. Okay, what is the meaning of open standard? Okay, allow multi-vendor deployment. So OSPF also configure in your HP switch, HP router, or your Dell router, okay, or IBM, okay, and Huawei, okay, or your Palo Alto,
And
okay,
Cisco.
and Checkpoint and Cisco, yeah, Cisco also. Okay, so this is the one very good advantage. Like OSPF can be configured in your all routers. Okay, as you know that it works based on your link state, right? Okay, there are the 2 types of packet available in your OSPF. That is hello and LSA. Okay, LSA means link state advertisement. There are 2 packet, guys. Please remember this. It might be the interview questions. Okay. Okay, how does this hello works? Okay, when a router A sends, okay, we can see, right? When a router A sends to any message, so these guys send a message to this guy. Okay, so we can say if this guy has sent any message to B router and C router as well. So when a router A sends, it send the hello packet using your, remember guys, this is a multicast IP 224.0.0.5. Okay, there's one more thing we are using, that is 224.0.0.6. Okay, these are 2 multicast IP used in OSPF. Remember guys. Okay, hello packet are received by all the neighbors. Okay, B will write DNA and its neighbor table. C also process the same way. Means B in the routing table, it will mention, okay, my neighbor is A. Same thing, he also update is topology table and neighbor table. He will write A inside your
routing table.
Topology table, neighbor table, not routing table.
Okay.
Okay. Don't get confused. The hello packet frequency send the frequently issue the packets. It also does negotiate and it will form the adjacency. Okay, verify continuous availability for adjacency neighbor. Hello packet and link state advertisement built by maintaining the topological database. It will maintain the topological database. Say example like, so how your network has been connected, how many people has been connected, that all database it will maintain by OSPF. Okay, hello packet are addressed to your 224.0.0.5. Please remember guys this one. Okay, this is how it will start negotiating, forming the neighborship. Okay, whereas EAGRP, which one? 10 by your EAGRP, correct?
Correct.
Okay, then link state advertisement, guys. Remember, so your link state OSPF data packet continue link with the static state and routing information that share among your OSPF routers. So LSA share only the router to whom it has been formed the adjacency. Okay, link state update advertisement, it will share the update only to whom it has formed the adjacency. Okay, so example like if you have the new neighbor has been come in front of your home. Okay, so once if they talk to each other, they form the neighborship, then you will exchange your mobile numbers and Instagram, Facebook, all details, right? Same thing here also. When they form the neighborship, then only it will send your updates, otherwise no. Okay, LSA packet are used to update and maintain your topology database. It will maintain the topology database. Okay, so again link state, what it has got means two types of table it maintain. Okay, neighbor table, your topology table, and routing table. Same like your EAGRP. Okay. So what is the neighbor table it does? Okay, neighbor table contain information about the neighbor. Okay, and neighbor is a router which share the link among the same network. So another relationship is adjacency it will form, not necessary for all the neighbor. Doesn't mean that it will form all the neighbors. It will form only the immediate neighbor. LSA update are only when adjacency is established. Okay, when the adjacency is established, then only it will form your neighborship. So whereas topology one contain information about all the network and path to reach to any network. Topology means how it has been connected. Say example, if you take this example, say, so let me write it down some points here. How does it going to work here? Say example, you have connected one more router here. Okay, and here also you have connected one more router here. Okay, so here if any changes means this guy maintain the only the immediate routing table of this. He is my neighbor. Say example, R1 is my for R1. Okay, R2 is the neighbor. Okay, and here say example, this is my R4 and this is my R6 and this is my R3. Now in the R2, this guy maintain how many table? Neighbor table. R4, R3 and R6. So these guy maintain these all tables. So when this guy reach to R2, okay, the R2 can able to route this traffic to anyone. Say example, so one of these PC want to communicate one of these PC available in R6 router. Say example, this is my Y and this is my A. Okay, when it's reached to R2, okay, this will route the packets. Okay, here what is the concept here means they'll OSPF is going to put in one different area. Say example, this is my area 10. Just imagine this is your area 0. Like this is going to work. Okay, because it will minimize your routing table, because you know router has got very less memory. That's the reason It will not keep the entire topology. It will show you who is my neighbor, okay, how many people has been connected to my route, my neighbor router. This is a very good advantage in OSPF. So let's jump for this one. Okay, for topology, same thing is talking about it. Yeah.
Can you come back on that explanation and go a bit slower?
Yeah, here. Okay,
Yes.
let me explain here. Okay. See, what is a topology table? Okay, topology means like how many people has been connected to your router, right? It will update. How means contain the information about all the network and path to reach to any network. It has got the lot of path has been connected. Okay, say example, you are connecting the two routers. Okay, again you have connected one more router here. Again you have connected one more router here. Now this topology table, it will show you, okay, example, this is my R2, R3 and R4. 3 routers. So in the topology table, if you check, okay, this all information will be there. For example, R2, R3 and R4. And path. Okay, how did this serial cable, say serial example 1, this is 2 and this is 3. You want to reach to the router 2 network, okay, go via this link. Okay, this link, what we'll call, this is called your WAN link, not the LAN link. The router which is connected inside your organizations, this link will call your LAN link. Means the topology table, okay, it will also has the path selection. Okay, it will update is your topology table. I hope it's clear, right? Any questions here, Angie?
Clear now. Thank you.
Yeah. So let me jump for yes, routing table. Okay, routing table, also known as forwarding database, generate when the algorithm is running on the topology database. Routing table for each router is unique. Okay, that we shall discuss in coming slides. Okay, OSPF has got some terms here. Okay, it has got the link, router ID, neighbor, adjacency, and area concept. Okay, you have to remember this. Okay, it form neighborship, router ID, adjacency, OSPF area. Okay, backbone area will be having, backbone area will call it as your area 0. Okay, we will be having n number of area. There is no limit. Internal router, ABR router, area border router, okay, autonomous system border router. That we should discuss. I will discuss in coming slide. So what is the link, guys? So link might be your fast Ethernet, gigabytes, optical fiber. Okay, the link state might be up or down. That's what he's talking about. If you see, maybe up or down. No. So let me discuss this point. Okay, remember, guys, what is DR? It is nothing but your designated router. Okay, BDR means border designated router. Remember this. And this is the link, how it is connected. The link is a network or router interface assigned to the any given network. This link interface will have the same information associated with it. Link has a 2 state, that is up or down, also known as your one or more IP addresses. Okay, remember now the router, say example, you are running here. Say example, you are running OSPF here. OSPF you are running here. So here you are running EIGRP. Okay, this router will call it as your, okay, ASBR router. Autonomous system border router. Okay, remember, guys, this router is connected to the another routing protocol. We'll call it as your ASBR. Okay, in the coming slide also we can see. Same thing here. So one more point here. Yes, so I want to tell you this. Okay, the information is propagated throughout the network unchanged and also used to create the shortest path tree. Okay, what does it mean, guys? When any table formed by any one of the router, as you know that, so how many table it formed? 3 table, right? It forms the 3 table, right? First thing is what?
Neighbor.
Neighbor table, then topology table and
Routing table.
routing table. Okay, 1, 2, 3. 3 table it form. Okay, for each router they form these, right? For all the routers, 3 table. All 3 table it form. Every router. So what is the every table has got the unique routing table, not the same. Remember, it will not be same. All are unique table. Okay, now suppose there's a lot of network connected. Say example, here you are going to connect 255 PCs connected. Any one of the PC want to communicate this network. One of the network you're running a lot of server, web server, exchange server you're running inside. You want to communicate this one of this PC. Okay, so how is going to select? Because whether it should go via this way. Okay, so maybe you are connected, he can go this way as well. This is called the possible routes. What are the different possible routes to reach to this ABR? Okay, now this algorithm, okay, the shortest path, it will form the tree structure. I want to reach to this PC. What are the possible path I can select? Okay, it will select always more than one routes. Okay, maybe if these links go down, what happened? It has to route via this, right? Okay, maybe you are connected like this also. Okay, even he can reach via this. Means 3 path, means it has a 3 path now. So like this, we can have the n number of path. Means you will find the redundancy here. Once links go down, automatically you can route the traffic to another link. That is a very good advantage in OSPF. I hope it's clear, right?
Yeah. Okay. Yes.
Yeah. So let's talk about what is the router ID. Router ID is an IP address used to identify the router. We can give the IP address for the router in the OSPF to identifications. The Cisco choose the router ID by using the highest IP address for all the configured loopbacks interface. So those who got the highest IP address, that guy will become the router ID. Okay. We can give the IP address, highest IP address, that guy will become we'll call it as your designated router. That is
Sorry.
DR. DR is nothing but a team leader. Remember, guys?
So,
yeah.
What does it mean, highest IP address?
Yeah.
What does it mean by saying highest IP address?
Okay. Okay. Let me tell you, because in your country, election will be happen, right?
Yes.
Okay. Those who got the highest vote, people vote to him. That guy will become your
President.
Same thing here. Who has got highest IP, that router will become president. Understood?
A little bit.
Little bit. Okay. I will explain in coming time. No problem. See, first understand here. Yeah.
Let me ask maybe in this way. We've got 2 routers, A and B. So router A is having 5 loopbacks. Router C is having 7 loopbacks. So it means that a router with a higher number of loopbacks will be the ID.
Yes. If you have the router, okay, 2 routers has been connected. Remember, this is what type of connection? This is point to point. Correct? Directly connected, right? If the point to point connected, no need to configure the area. there is no election process. Right? Point to point connected, no need to configure any area, just configure the OSPF normally how you configure RIP on EHRP. Okay, there is no election process. Okay, by default, okay, DR, okay, BDR, okay, is not required. Say example, as per your question, you have created 5 loopbacks here. And here also you create 5 loopback. Okay, highest IP address among the loopback, that router will become your DR. You can see that if no loopback interface is configured on address, OSPF will choose the highest IP address and of all the active interface. By default, it will take. If you're not configured no loopback, say example, I have configured this 192.168.10.1. Okay, this guy will configure with 20.1. Means this router will become your DR now. Okay, that is your router ID you configured. Or else we can manually also we can configure. You want to make only this guy this one, we can give the highest IP address here. So example, this is like 100.1 we can give. Highest IP address. Or else manually also we can give. Whichever you like. Okay, so now when you have to configure, the router ID must be always up. Therefore, loopbacks are preferred. What does it mean, guys? Router ID must be always up. Because the router ID is down means your entire network is down. Remember this. Therefore, that's the reason your loopbacks are preferred, because loopbacks is your virtual interface, right? There's no physical interface. That's the reason. Okay, your router ID must be preferred, will be the loopback. Got it, guys?
Yes.
This is quite very important to understand, guys. Okay, let me jump for and come to this neighbor. Okay, neighbor are 2 or more routers that can have the interface in common. 2 routers connection on the serial interface, several router. Okay, frame relay. So frame relay will not discuss. The communication take place between the 2 adjacency will form. Okay, this is a lab part now. So he's talking about, we'll do the basic lab now. Adjacency means just exchanging their links, exchanging their routes. Not all the neighbor will form the adjacency. This is done for the reason for the efficiency more later. Okay, not all the people will form the neighborship, right? Okay, this is what, guys. So please understand. So for OSPF, okay, every OSPF configuration, you must have the area 0. Okay, and there might be more than one area, maybe 10, 20, 30, 40, 100, no problem. Okay, the router which is connected to the other area, we'll call it as your area border router. Okay, the router which is come under the area 0, we'll call the backbone router. Okay, the router which is connected to another, say example, another router you are connected here. Okay, we'll call it as your autonomous system border router. Understood, guys?
Yes.
Okay. So one more thing is, yes, he's talking about OSPF, a group of contiguous network share among the common area. Contiguous means you keep on sending to the updates. Okay, that we shall do the lab part. Router can be member or more than one area. Okay, for one area there might be n number of area 1, 2, 3, 4, 50, 60, because one area they will be having a lot of network connected. Okay, all the routers in the same area have your same topology database. Topology will be same because you know how it has been connected will be same, right? Only the routing table will be unique. When multiple area exists, there must be always be the area 0. If you have more area, Keep in mind, so you must have the area 0, which is the backbone area. Why this area concept? Decrease the routing overhead. So compared to the multiple small broadcast domain instead of your one large one. Because unnecessary, because a lot of area everybody will communicate. We suppose example, so entire big city, so example in the Bangalore, I think most of the people visited, right, Bangalore. Okay, see, it is a very big city. Just imagine, okay, you'll be having only one office. All people will come in the complaint for any government job, any office, application, work, all kind of work will come and visit to one office, right? Correct. If you have the office with a different area, okay, south, north, east, west, one office, if you divide, okay, only those area people can visit to only south area office. Same as your west area, only west area office they can visit. Like this, they are divided. Same thing here also. Means instead of doing your multiple small broadcast domain instead of the large one. If any changes, it will update to all. Okay, one more good thing is it will improve your speed convergence. Okay, so config for your network. Okay, so config your this thing network, say example of flipping of the single area. Okay, just you are dividing, guys. So as I told you that, one more thing, CCNA certification deal with only single area. But right now the Cisco has been changed. We'll do all your multi-area lab. Not one area, like multi-area lab also will do it. Okay. So same thing, I think I told you, right? This is a backbone area, this is how the topology look like, guys. So can we jump for the lab now? Guys?
Before you go, in the backbone area, we've got, is it router A and B?
Sorry?
In the backbone area, I've got router A and B. Now, B is backbone router. Is A again backbone router, or it's having another name?
Yes, in the area 1, we will be having a lot of area, no problem. See, if you talk about what you are talking about, this thing, let me explain this one. Say example, this is your area 0, right? So in area 0, we can run a lot of router inside. Okay, and this one also we can connect to other area. Example, this is area 1, and here also we can connect one more area. This is area 2. Okay, inside we can run a lot of router. Inside a lot of huge network has been connected. Same like, okay, so this guy also connected with other area. Means what is the advantage by doing this, dividing the area means, okay, if any changes in the network, okay, maybe I think this area is connected with the other area. The example here you are running EIGRP. Okay, here you are running RIP. And this router will call ASBR. Okay, and this router will call ABR. Okay, so now if any changes in the network, okay, you added the one more new department in your organization. Okay, so this guy, even though they can connect in this way also, guys, they can connect this way also, but they cannot give the update to this router directly. They should give only update to the area 0 network. Remember, okay, This area is, as I told you, that it is a backbone area. Only area 0 will broadcast to all your areas. Got it? Means like this, it will not consume the more bandwidth. You know, bandwidth is very expensive. Because what happened, each one is connected directly to each other. They cannot send it any new updates, new departments. Say example, this is the HR team. They have come up with a new team. Okay, so they cannot give any updates, even though they have connected directly. This is a very good advantage. I hope it's clear.
Yes, it is clear.
Okay, so let me explain some of the points here before we jump for the lab. Okay, the configuration of how do we configure. And one more thing is, let me explain the path calculation of the area. LSAs, we shall also discuss the LSA. Okay, the path selection, guys, remember here. So let me explain the path selections. As we can see, re-establishing the best path selections will be depending upon your algorithm. Path selection will be totally depending upon your algorithm, guys. That is shortest path first by computer scientist name Dijkstra algorithm. Okay. This is done by each individual router by using the knowledge that is the whole network. Lead to the rapid and accurate convergence based totally upon your every link, totally depending upon the cost. Okay, the cost. Okay, cost will be depending upon your the link speed. The lower the cost, the better the speed. Okay, that also we shall discuss now. So as we can see here, the OSPF is totally depending upon this equation, guys. OSPF cost 10 to the power of 8 divided by the bandwidth. Okay, this is how it's going to calculate. So do not forget to configure the bandwidth common on the serial link correctly, especially when you are using the serial. Okay, we should configure your clock rate. Okay, let me explain this point. Is quite very important to understand this one. Okay, OSPF network type, guys. Okay, you have the broadcast multi-access, point to point. Okay, non-broadcast multiple access in OSPF. Guys, OSPF is a very vast protocol, guys. It's very big. Every organization throughout the world using the OSPF. Okay, the frame relay. So nowadays we are not using frame relay. So instead of frame relay, so now it has been switched to SD-WAN. I think SD-WAN means, I think you know, right? Software defined network. Now, how the DR-BDR election process will be happened? DR-BDR election process will be happened. Point to point for all the network will form the adjacency. Doesn't require any election process. So NMB or broadcast multiple access and non-broadcast multiple access, one router is elected as a DR. DR means nothing but a president of the country, team leader, head. Okay. Whereas DR established adjusted for the each neighbors, LSA update, link state update are exchanged only to DR, as I told you that. If you got any update in other area, it has to give update only for DR router, not only even though it is connected directly. Is as simple as this, guys. Let me explain. Okay, this is your team. Okay, there's a lot of people inside. Maybe you have 10 people. Okay, you have one of the big head. He is your manager. Okay, so he is your manager. Say example here, say Malice. He is your manager. So we people are working for some company. Means in this there will be one team leader. Okay, they will be team leader. Okay, if any one of the guy has got some issue, he can directly contact to the team leader, not to the directly for your manager. Okay, now the election will be happened those who got the good experience, right? Okay, here, okay, DR is the router which has got the highest priority, the highest priority. All the Cisco router has got the same priority value 1 by default. Now, who is going to all the Cisco priority devices has 1. So, example, you have the 2 router, the priority is 1. What happened now? This also priority 1. Okay, this also priority 1. What happened now? Who will become the team leader now? Who will become team leader? Team leader means I'm talking about DR, guys. DR means designated router.
Highest IP addresses.
Yes, highest IP address. Okay, the priority is thing, because manually also we can give. Okay, manually also we can give. So if the priority is same, then the router ID is C. What is router ID? We can give the IP address. IP. Give the IP address. So example, okay, this is my R1 and this is my R2. Okay, I can give the IP address, highest IP address. This guy will become the DR now. And this guy become your non-designated router, NDR. Understood? Okay, so now he's talking about the point-to-point link. Okay, if there are no DR-BD election required, guys, please remember this. This point is very important to understand, guys. If directly connected, guys, no need to have any election process. No BD/B election required. OSPF auto detect the interface type. OSPF packet send using multicast IP, using this IP address it will send. All the router form the adjacency if it is directly connected. No need to have any election process. And for here you require the election process. Remember. So example, this is my DR. What happened? Generally, LAN technology link Ethernet token ring DR-BD election are required. All the neighbor router form the adjacency with the DR and BDR only. Will form only with the DR and BDR only. Packet sent to DR using 224.0.0.6. Packet sends to DR. Say example, you have updated new network inside. Okay, this you cannot send directly to this router. You can send only to DR using which IP? 224.0.0.6. Okay, packets sent from DR to all the router using 224.0.0.5. Okay, means this is a new network. Okay, please take this new update from your routing table. Please update your routing table. Just informing. So this guy has changed some new network has been added in their organizations. Please take this update. Understood, guys?
Yes.
Same thing is talking about the election process. Okay, so summary, if you talk about, so actually what is the AD value for here, guys? It is 110. Hop count unlimited, metric will be calculation cost, okay, minus 10 to the power of 8 divided by bandwidth. It is a classless routing. It supports the subnetting also. Load balancing up to not 6 routers, it's up to 8 routers. Up to 8 routers, it does the load balancing. Like traffic control, guys. Load balancing is it is nothing but a traffic control. Required more processing power means your router, when you purchase the router in your organization, make sure that router should be high speed, especially your microprocessor. and your RAM should be high end, because OSPF consumes more hardware resource. Remember that. Okay. So now if you talk about the basic configuration, guys, so I think configuration, if you see, how do we configure? Configuration is quite very simple. Let me show you this topology example. So we can see the configuration part. How do we configure? We can see OSPF, okay, and this is the number. This number we'll call it as your process ID. This is not an autonomous system number. How we are we have done in EAGR. This is the process ID. Network, which network you want to today's with the wildcard mask, not the subnet mask here. With the area, which area you want to put. Okay. And network, say example here he's running 10 network and 20 network. Same thing vice versa. Okay, this lab will do it. Okay, so we'll take small break now. So after the break, we'll start doing the OSPF lab, guys.
Okay.
Hello, Touch.
Yeah, sorry.
Would you please share us the slides?
Yeah, I will share you. No problem. I'll share you the lab also today's lab also I'll share you.
Okay.
Yeah. Yeah. We'll see after the let me put it on the screen. I will write it down here. Break for 15 minutes. Coffee. What is coffee spelling?
Double F.
COF.
Yeah, double F.
COF.
COFFEE.
Okay.
Double E as well.
COFF.
EE.
EE. Coffee.
Yes.
Okay. Because some people they are watching from YouTube. Okay, see you after the break, guys. Guys, all of you there, right? I'm back here after the tea break.
I'm available.
So can we jump for the lab now? OSPF lab.
Yes.
Okay. I hope all people are there, right? So let me open the existing topology. Okay, let's take a RIP. Okay, guys, so I'll be using the same topology as we can see on the screen. So just I will change, I'll remove the, I think this is a RIP now. I'll remove the EAGRP. So let's check what it has in configured. Yes, configure the EAGRP. I'll remove the OSPF, same topology. Show IP route. So it has configured the EAGRP now, we can see, right? So I'm going to remove that. So go to global configuration mode, no router EAGRP 100. I think yesterday we had given 100. Done. So if you type again IP route, it has removed the all configuration. Same thing I will do for this router as well. So no router EHRP 100. That's it. Show IP route. Now everything is removed. You can see both the configuration, just all the IP address is assigned already. As we can see, the one network is running here and two network. Okay, so what I will do, I will change this file name as say OSPF lab 1. Okay, so here also I will change OSPF. And here also I will change to OSPF. Okay, guys, everything is configured. The IP addressing basic configuration is done, assigning the IP address for all the interfaces. So as we can see, all the interfaces up. Okay, right now we'll not use the last router, third router. Just will configure only between these two routers. Okay, so let's configure, guys. Guys, all of you there, right?
Yes, we are.
Yeah.
Yes, sir.
Yeah, so let's configure the OSPF now. So let me make it this topology as big. Okay, so now we can able to see the screen, right? The configuration, like how you configure the EHRP, same thing OSPF. Go to global configuration mode. Okay, router OSPF. Okay, we can give the question mark, and this is called the process ID, not the autonomous system number. This is called, we can give up to 1 to 65,535 process ID. We can give any number, but it should be the same number. So let's say I'll use 100. Okay, then network, I have to advertise my network. What is my network running in this router 1? That is IBM router. That is 192.168.1.0 network. I give the question mark. So here is asking the wildcard mask. We can see it is asking to enter the wildcard mask. So wildcard mask for this one is, what is the wildcard mask for this one?
255.
255?
0.0.0.255.
Yes, 0.0.0.255. Very good. It's a wildcard mask, not subnet mask. Okay, then give the question mark. Now he's asking the area. Which area you want to put this router? Set the area for the OSPF. So I'll put in area 0. Area 0 is your backbone area. Okay. Okay, there's one more network, that is 10 network. Okay. Now you tell me, guys, what is the wildcard pass for this? What is the wildcard?
0.255.255.255.
Yes, 0.255.255.255. Okay, this also I'll put it in area 0. That's it. If you type show IP route OSPF, okay, type OSPF, so still it will not show you the any update. It has not formed any adjacency. It has not loaded any updates. Means we should configure with router 2 as well. Okay, let's configure the router 2. So go to global configuration mode, router OSPF 100. We should give the same value, guys. If you give different means they'll not form the neighborship.
Sure.
The network, which network I should advertise here? 192.168.
2.0.
Okay, very good. 2.0 and next, what I should give?
0.0.0.255.
Yes, this also I'll put it in area 0. Because right now this is a very small network. If we have a big network, then we will do multi-area. The next step we'll do multi-area. Okay, one more network is 10.0.0.0, then 0.255.255.255.0. That's it. Is it anything we are missing? Can you see? Notice here, it's loading here. They have formed the adjacency. If you type show IP route, okay, we can see 0. O means OSPF. What is this 110?
Administrative distance.
Yes, very good. This is administrative distance, OSPF. Okay, we can see the OSPF O. OSPF is configured with the OSPF 0. Sorry, O. And 65, he has calculated automatically the metric calculation. Because it is a directly connected using serial link, that the reason automatically has calculated the bandwidth. Let's check with this router now. Show IP route. Okay, 2 network has done. Okay, that is your OSPF. So can you able to ping to that network? So 192.168.2.1. Yes, I do have the reachability. Okay, there are many ways show IP route or IP route OSPF. Okay, it will show you only the OSPF routes. If you type who is my neighbor, show IP OSPF neighbor, okay, it will show you who is my neighbor, 13.1. Who is 13.1? The loopback, which we have loopback. Right, so in this router, we have created a lot of loopbacks. Show IP interface brief. We can see, right? These are the loopbacks. Okay, now I will ask the very important question, guys. Please give some attention here. Why it is showing only 13.1.1.1 loopback? Why it is not showing these two guys? Neighbor, why it is showing only this guy?
It is
For this router, for this router, okay, router 2 is the neighbor. Okay, why it's showing this only this guy?
Because this is ISP and it is DR now.
Right, because as per this one is this router 2, okay,
DR.
router T is your DR, designated router, because as per our slides, what I explained, okay, loopback is a first priority. That's the reason this guy is your DR. Okay, so let's check how to change this, guys. So let's say I want to make, okay, IBM router as your DR. How can I do that? Suppose if I check from this side, okay, show IP OSPF neighbor for him. He's showing 192.168.1.1. Okay, let's create one loop back here. Let's see. In router 1, I will create one loop back, interface loopback 1. Okay, so I will give an IP address. Say I will give IP address this 1.1.1.1. Okay, subnet mask I'll give 255.0.0.0. And show IP interface brief. I have created one loop back here. Okay, let's see how now it was showing 1.1.1, right? Now check once again. So it's showing same. Because we have created the loop back, because highest loop back will be considered. 13.1 is the highest loop back than 1.1.1. Okay, that's the reason. So how do I change the router now? I want to make this router 1 should be my DR. How to change that? Router OSPF 100 router ID. I can give the router ID. Okay, router ID this time I will give 15.1.1.1. Is it okay?
No, sir.
It will get effect. See, is showing, please clear the OSPF process to get the update. Clear IP OSPF process. I will clear this one. So reset all the OSPF process. Yes or no? Yes. I will say yes. If you type show IP OSPF neighbor, so this guy is showing, we can see it is initiating. This is nothing but your hello message. It will forming the neighborship. Now exchanging. Now exchanging now. Now it has got the loaded. Now if you check OSPF neighbor, for him neighbor is same. Okay, now we check this side now. Now we can see it's showing 15 network. Previously it was showing 1.1.1 is my neighbor because he has considered as this is my loopback. Loopback is considered first one. This is how the selection of DR, BDR lab. We can make it team leader anyone, guys. You can select by giving the highest IP address. Recommended is create the loopback and give the router ID. That's it. Very simple lab. Understood, guys? Clara, Isaac, Malice, Angie, Asma. Understood, guys? Andrew.
Yeah, understood.
But now who is DR? Arwan? Who's DR? IBM?
Okay. Let me. There's a lot of command is there. I will show you that. Okay, show IP OSPF. A lot of command we can type here: database, interface, neighbor, virtual. So let's say I will check who is my, as you said, DR, router ID is 13.1. This is, I am into router 2 now. Okay. So how do I check this one? Show IP OSPF database. Area 0. Okay. Means this is router 2 is your DR. Router 2 is your DR. Now, how to make this router 1? How to make this router 1 as a DR now? See, router ID, what we have given. Show IP route OSPF Q interface. We can see we have given this DR is a 50. Okay, state is DR. Okay, when you are given the 15 network, means your router 1 has become your DR. Can you see here? State is designated router. Now check the same command here. Show OSPF, not database, right? It is an interface. Show IP OSPF interface. Show IP OSPF interface. So this guy also showing the DR because you know why? It is directly point-to-point connected. Okay, it doesn't do the election process because when you have more than one area, okay, right now this all are belongs to the area 0. These all guys are belongs to area 0. So let me remove this all coloring what we made. These all guys are belongs to area 0. Let it put it in very light color. These all guys are belongs to the area 0. Area 0. That's the reason it's showing all our BDR because you know in OSPF the one router should be the because it's not doing the election process. Because you know if you have more than one area, that is our next lab. We are going to do that. Okay, let me save this one. I hope this clear, guys.
Yes, yes.
Okay, I will save this.
Can you run show IP interface brief on router 1?
Okay. Show IP interface brief.
Okay,
Where
so
to-
the 15.1.1.1 that we have set as the router ID does not appear anywhere. Because we
showing-
manually
Yes.
because we manually put it
If you
as the
type
router
show
ID.
IP OSPF interface, so here it's showing router ID is 15,
Yes.
right?
Would it be the same if we just added another loopback with that IP? Would it work the same way?
Yeah, you want me to create?
If instead of changing the router ID manually, the way we did when adding 15.1.1.1, we just added another loopback interface
Okay.
with that IP.
Yes, we can add.
uh,
Okay, so I will add 16 now this time.
yes, yes, yes.
Okay. Now you type interface. Okay, neighbor is showing 13 network. Okay.
Yes.
And the router ID is showing 15. Okay. Now you check this guy now. Show IP OSPF neighbor. So he's showing 15.
Okay, so
Because in the here there is it's not happening the election process because only two router, right?
yes, yes.
Only two router. If you
Because
have a
it's
lot of
point to
people,
point.
because it is a point to point.
Okay.
The communication is point to point, doesn't require any election process. I think in
Alright.
on the slide, I think I have showed you, right? Somewhere here, I think. Yeah, router ID with the highest priority selected the DR. Okay, when you have a lot of these things. If the priority is same, the router ID is seen. So use the OSPF router ID as a tie breaker. See, when you have the point to point, okay, usually no BDR and DR election required. When it is a point to point. This is the topology, right? What we have connected, right?
Yes.
Got it?
Yes.
Okay, now we will do the multi-area lab now. Okay, this is the one single area. Okay, we will take this one again. This router, I'll put it in a different area now. Okay, I will save this one. Let me send you first because you will get this thing. Let me export these files. Where is OSPF? Yeah. OSPF lab1.txt. Okay. Okay. So let me send you these files. I hope you received this thing, right? So someone is asking yesterday's lab also. I will share you yesterday lab as well. That is EAGRP. Okay, so I have shared you both the EAGRP and OSPF. I think Andrew, I think you asked me, right, yesterday?
Yes, I did.
Yeah, so I think you received it. We can download, you can open in your packet tracer. Okay, let's do the multi-area now. OSPF multi-area. So what I will do, I will copy and paste. Same topology. And this I'll make it OSPF lab 2. Multi-area. Okay, so now this is my, I need to change this topology now. Okay, guys, first understand like how we can design this topology, okay? The center router is your OSPF 0. Okay, let's put it like this. Let's put some colors. Okay, so up to here, these guys are belongs to the area 0. Okay, I have not selected the color. Okay, this is not a perfect color. Let it take the square box. So up to here is area 0. And green color, this guy is your area 1. And this guy, I'll put it in area 2. Understood, guys? I think this also belongs to the same area. I think we should take the same color. Okay, this guy also in the same color. First understand, okay, the area which is belongs to this blue color is belongs to the area 0. The yellow color still you have not connected the network. I will connect it. The green color belongs to the your area 1. So example, we will take area 10. Okay, and this guy will put in area 20. We can give 2, 3, 4 also. The blue color which here we can see, these people are belongs to your area 0 OSPF. Okay, so let's connect some switch in this network, some end user devices. I will say laptop, one server. Let me connect auto. So what is this network? I think I should give. So 192.168 3.0 network /24. Okay, and network ID. What is the network ID for this one? So 192.168 3.0/24. Okay, understood, guys? You want me to explain this topology before I jump to the lab? See this network, which are the blue color, what we can see, these people are belongs to the area 0. And this network, what you are running here, these guys belongs to your area 10. And this network, yellow color, belongs to your area 20. Okay, so let me make it big. Let me write it down. It did not require. Okay. Okay, let's open now. Now I'm going to start the lab now, guys. OSPF multi-area configurations. Okay, right now, previously we configure EH OSPF itself. Let's remove that. Okay, no router OSPF 100. Okay, same thing this side. Router 2. Guys, is it you are following me or I'm going fast?
We are together, sir.
Perfect. Okay. No router OSPF 100. Now everything I have removed. If you check show IP route OSPF, no routes available. Same thing if you check this side.
Sir, you are a little bit fast
Sorry.
because I was following before and I didn't configure mine. So I need to configure this, make it slow, little bit.
You want me to go slow or fast? Tell me fast.
You have to be slower, sir.
Slow.
Let's design topology. Let's first finish the topology and let's together configure.
Together configure means it takes long time. Malice, when I can complete? Do you know what are the content I need to complete?
Oh, okay.
You want to see?
Oh,
If you see this Palo Alto, not this one, CCNA. See, these are the topics I need to cover. See, very huge topic. Still switching not yet started.
we need to cover this all today?
Not today, in coming weeks. See, in another 3 weeks, I need to complete this topic. When I can complete, guys? What do you think?
No,
CCNA?
sir.
When I
Sir.
can complete this? If you try to,
Switching is easy, sir.
for you it is easy. What about other your friends?
I'm sure it's easier than OSPF. Routing is big issue, sir.
I know, man. Because what about there's the new people joined here, right? From Malawi, from few other guys. They don't know about this. First time they are attending. Like Clara, Angie, Asma,
Okay.
Andrew, and Isaac. Because first time they are learning.
Okay. Okay, sir.
See, again, they have a redistribution again, next lab. Then again, ACL, then NAT, network address translation, WAN technology. Again, in the CCNA, they have started wireless. Okay, in wireless also one more thing which I forgot to teach you, that is automation. That one also I'll teach you guys. Automation is quite very easy. Then I need to start switching again. If you're trying to do, because that's the reason I'm recording this session. Okay, I'm sending all the files, what are the lab I'm doing it, right? Okay, if you find any problem while doing the lab, say one day we'll put separate only for solving your issues when you face any challenges in your lab. Okay.
Okay, sir.
Yeah. Okay, so now let's start with the lab, your OSPF configuration. First, understand, guys, right now I'm in router 1, that is the IBM router. We can see, right? I am in the IBM router now. So let's change the host name also so that we can avoid host name, that is IBM. Let's say I'll give capital IBM R1. Okay, so let's configure this. Go to global configuration mode, router OSPF 100. Okay, this time I will give 10 for all 10. Okay. Now network 192.168, that is 1.0. Okay. Then give the wildcard mask. What is the wildcard mask for this? 0.0.0.255. And this belongs to which area? Which area, guys?
Area 0.
Area?
10.
0.
10.
Area 10.
Area 10, man. See the topology. You can see my this all right cursor.
Okay.
Okay, this is area 10, not area 0. Area 0 is only the blue color. The blue color should be only in area 0. The green color is area 10. Same like yellow color is area 20. See here. Yellow color belongs to the area 20. Your green color should be belongs to area 0. Only the blue color, what I have written here, this should be the area 0. This is your area 0. Okay. So this should be the area 10, correct? Understood? Andrew, Isaac.
Yes, yes.
Yeah.
Yeah, understood.
Now, one more network. Which network? 10 network, right? You can see my cursor there. Right? 10.0.0.0 and give the wildcard mask. Wildcard mask for this is 0.255.255.255. And this should be which area?
Area 0.
Perfect. It should be the area 0, right?
Yes.
Yes. Now this is done here. Now we'll jump for your router 2. That is your Dell router. Guys, you know Dell company?
Yes. Yes.
Yes.
No, I think Indian people, they know, or Dell. Michael Dell, you know Michael Dell? Who is the owner of Dell company? Okay, so let's configure this router now. Okay, so right now I am into the router 2 now. There is a Dell router. Okay, router OSPF 10, right? Network 192.168.2.0. Okay, give the wildcard mask. The wildcard mask for this is 0.0.0.255. And this should be area. Which area?
0.
Area 0.
Perfect. Now one more network, 10 network, right? 10.0.0.0. Then wildcard mask. What is the wildcard mask for this?
255.
0.25.
0.255.
And it should be area. Which area?
0.
Yes.
Area 0.
Area 0.
Area
Perfect.
10.
Okay, then next what we should do? We can see red is loading. Adjacency is forming. Then next, what next? Is it something you are missing? Network, one more network. Which is that? Who will tell this one?
20.1.1.1. 20.0.0.0.
Perfect.
192.168.3.0.
3.0. 3.0 is a router 3. We are in router 2. Right? We are into router 2 now. We are in router 2, not in router 3. So remember, if you are in router 2, remember guys,
2.1, sir.
20.111, sir.
see one network. Okay, in area 1, how many are there? This is one network. Okay, this is second network and this is third network. All are belongs to area 0. Understood, Asma?
Yes.
Okay. So let's configure this one more network, 20.0.0.0. I think Andrew told the perfect answer. This indicates that you are learning from me, Andrew.
Thank you, noted.
Yeah. Okay, then what is the wildcard mask for this?
0.255.255.255.
Okay, then area belongs to which area?
0.
Area 0.
Perfect. Done. Now, last router now. So we can see these links are down. Can you see? Okay, means we should configure the IP address for serial interface, right? So go to global configuration mode, interface serial 0/1/0. Okay, IP address 20.1.1.1.255.0.0.0. So we can see the moment I have given, it formed the adjacency. Because it is a clock rate we should give, right? DCE interface. Oh, IP address we have given for wrong, guys. What mistake I did, guys? Please check. What was the mistake I did?
Please show IP interface brief.
See, I have given the IP address, this 20.0.0 network. Can you see? This IP address, I have given 20.1.1.1.
Sir, do show iPad interface, please. Do show.
Okay. Do show IP interface brief.
Yes,
Means we have given the wrong IP address.
wrong iPad.
Okay. So I say no IP address, then IP address, I should give back to this 1.1.2 255.0.0.0. Okay, I'll say no shut. Okay,
By
if you
the way,
type,
sir,
Hmm?
if you don't want to assign IP address, you can do no. But if you don't want, you just it will remove that one. You no need to say no. You just when you give a new IP
Yes.
address, it will assign the new one.
Yes, just say no IP address. That's it. No need to give entire IP address.
No, what I mean is, sir, you
Hmm.
don't need to say no. You just give a new IP address, it will assign the new one, overriding the before one.
Yeah, it will come because in the real router, okay, you should remove the IP address. We should give the new IP address. That's the reason I'm doing this now.
Oh, okay.
Because this is the software based, right?
Okay.
Okay. Now this serial interface 0/1/1 is connected to router 3. We can see this is down. 20 network, we should give the IP address for this interface, right? Interface serial 0/1/1. IP address 20.1.1.1 255.0.0.0. Then give the clock rate 64,000. I say no shut. Okay, now it is up, right? Can you see it has come up? Because that side already we have configured that. Right now it is coming up now. If you type show IP route OSPF, okay, still is not yet learning. Still it is not yet learning now. So let's do the configuration this side now. Okay, show IP, check the interfaces. So here he has got some loopbacks. Loopback will configure later, not now. Just will configure only for this is router 3, right? So he has given 0, I think 3, it should be 2.1. It should be the 3.1 actually, right? We'll remove that, we'll configure that one. So go to global configuration mode, interface, gigabyte 0/0/0, IP address 192.168.3.1. Okay, so I say no shut. Do show IP interface brief. So I removed that IP address, we have replaced to 3.1 because this is my 3.1 network. Okay, loopback, we'll do it later. Loopback, not now. For serial, he has taken 10.1.1.2 because this is previous topology we copied. We have to remove this IP address. Okay, so I'll go to that IP address interface serial 0/1/0. IP address should be 20.1.1.2. Okay, so I say no shut. Okay, now we are going to configure the OSPF now. Okay, router OSPF 10 network 192.168 3.0, right? This is 3.0. So what should be my wildcard mask for this? Correct. And this is the area?
Yeah, 20.
Area 20. Then one more network. Which network now again?
20.1.1.
20.0.0.0. Then 0.255.255.255. Then area?
20.
Area
Area 0.
0.
Area
Zero.
0.
0.
0. Yes. Show IP route. Okay, still this guy is not learning. Okay, let's check with this middle router. Show IP route, no. Router 1. Show IP route OSPF, no. What is the problem, guys? Why it's not learning?
The 20.1.1.1 network.
That is IP address. We should configure with the network ID, not with the IP address. Check slowly.
Show run. Sir.
Check the IP addresses, all the IP addresses what we configured. Okay, this is 1.0 network and 10 network. Okay, perfectly we configured. So show run. Yeah, so this is what we configured. Router OSPF router 10 network, and we have given the wildcard mask. This is 1.0 network is your area 10, and 10 network is running under area 0. Here, no problem with the configuration. Let's check with the R2 now. Show run. Okay, area 10, OSPF 10. 2 network belongs to the area 0. Okay, these all are belongs to area 0 itself. 10 network and 20 network. Okay, let's check the interface. Show IP interface brief. Okay. 2 network perfectly configured. Guys, can you find out the mistake here? Henry, Malice, Clara.
We didn't configure the IP address on serial 010.
Okay, so what IP address I should configure?
10.1.1.2.
Perfect, Clara. Very good.
Yeah.
Very, very good. Okay, I'll configure this. I'll go to serial 0/0/1/0 IP address 10.1.1.2. Okay, say no shit. Then I think I should get the update, right? Can you see it's loading, right? Now it is forming adjacency now. Show IP OSPF. Still is loading because it takes time to load. So let's check in R1. These guys are loading. Now we can see, right? Perfect. Right. 2 network has learned, 20 network and 2 network has also learned. Okay, now you check once again here. He has learned 1 network. Okay, so what about this guy? Show IP right OSPF. Why this guy is not at learning? He has not learned. Check show IP interface brief. Okay, 3 network is up, no problem, and 20 network is also up.
Your answer.
Okay, you want me to check show run? Show run.
Go to OSPF.
Okay, we have to remove this EAGRP first. OSPF 10. Okay, 3 network is belongs
Correct.
to area 20 and 2 network belongs to the area 0. So we have to remove this one. So let's remove because it's getting conflict. So no router EAGRP 100. Okay, so is there anything else? Is it correct configuration, guys?
On which router you are?
I'm in R3 now.
Correct.
Is it correct? Show IP interface brief.
They all are up, so no problem.
No problem. Now check this router now. Show IP interface brief. Check whether we have configured as per the topology. This is serial 01/1
Correct.
is correct. Okay.
Zero.
And
Zero
this
one
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 also is
also
correct. Okay, and IP address for gigabytes is also up. So what is the mistake? Show IP route OSPF. He has learned one network. He can ping to one network, no problem. So 192.168.1.1. But I cannot ping to 3.1. Even in router 1, if you jump, okay, I can reach up to 20 network. You can see, right? You can reach. So 20.1.1.1. I can reach 20.20.2. From 2, it is not reaching. Correct. This is how we have to check, guys. If you do the any T-shoot troubleshooting, okay, so what could be the issue? Success rate is 0. It's no communication, but 1 it is pinging. Means the packet is reaching up to here.
Yes.
Right. Your packet is when you ping any one of this server to PC, okay, is reaching up to this interface, but it is not pinging to this guy. Means what could be the issue now? You can able to ping here because this guy can communicate to this network as well, no issue. They have the communication, but not with this one. And these 3 network is not available in router 2 routing table, and router 1 table also is not getting any updates.
Yeah. Go to Dale router and please show run. We need to see the IP address assignment.
Yeah.
Did I have
Check.
2? Yes, correct.
Can you ping 20.1.1.2 from here? From router 2?
Yeah, it will ping. No
Of
problem.
course.
Of course, because it will ping 20.1.1.1.
Because it's directly connected.
Directly
No,
connected.
.2.
It will ping because it is directly connected.
Mm.
Sir, please show run so
Sure
we
run.
can trace. Mine is actually correct. I already finished and correct, but here let's find this problem. Area 0. Sir, all are 0, correct. So go to another router, router 3.
Yeah.
Show
run.
Yes.
Yeah.
IP assignment. Let's see IP address assignment. Where is the gigabit interface?
Show IP interface brief. Okay, so this is the interfaces is up.
It's already up, yes.
Yeah, so this is gigabyte 0/0.
So show run. Let's see the OS space.
Show run. So this is the configuration.
Now, sir,
Hmm.
in area 0, in both of these two routers, 2 and 3, we need to choose the wildcard mask. 255, 255, 255, right? 20.0. Check the router 2. This one, yes.
Yeah.
It's correct. It should work.
Yes. Okay, I will do one thing. I will go to the last router now. Interface gigabyte 0/0/0. I say shutdown. I say no shutdown again. Let's say show IP route OSPF. Let it read the entire thing now.
No result?
No result. No result. It's not getting any update.
Show IP route OSPF never.
It's showing 3 network. Who is 3?
13 loop, I think the loop back.
Loop back. Okay. Is there we configure any loop back guys here?
Yes.
Here. Okay. If we check here also same. Show IP interface brief.
The same.
Understood? What is the issue?
They have the same loopback IPs.
Still, I'll give 2 minutes time. Okay. Meanwhile, I will have my water and come. I will drink the water and come.
Hello guys, what's happening here? Everything is correct.
So, do we remove the loopback IPs from one router?
No, loopback is already not inside any OSPF area, so no problem. It affects only its own. I mean, inside each. How can I say? Inside area, there is DR and DR selection, right? It will affect only that one. It cannot cross another area, so no problem with the loopback.
Got it, guys? Answer? Can you tell me? Anyone got the answer?
Sir, I think the problem is, I think we assign IP address 20.111 and 10.111, but we use the network 20.000. Maybe the issue will be there.
Nice. What is the network IP for the 20.1.1.2?
See, configuration we have made perfectly, right? So 20
It's
network.
20.0.0.0 because it's a /8.
It's a /8, right? It's correct. And
Yeah,
here also
/8.
it's correct.
It's /8, yes.
Okay, what we have to do, guys, just remove the loopbacks.
Yeah.
Yeah, that one she said also.
Correct.
Mm.
Interface.
So,
okay, see
sir,
what we did, loopback, because you know what I did previously. Okay, I copied the same router here. We can see, right, loopbacks. Loopback 1, 2, 3, 4, 11, 12, 13. And here also we can see 11, 12, 13.
Yeah.
Right. How to remove that? Interface, loopback, no IP address. Loopback 2, no IP address. No IP address. Now you text.
What if we say no interface loopback 1?
It will not work. So no
Interface?
say
No.
No interface, loop back one.
Loop back one.
Just I remove the IP address, like this also we can do it. Show IP
Oh.
route is one network still is running. Let's remove this guy as well. Okay, no loop back,
No interface.
no interface, loop back one, loop back two, loop back three.
Three. So now
Show IP route, show IP route. Still no. Hmm. But this guy has
sir.
yeah, Malis.
You said clock rate before.
Where?
Please show the interface, serial interface, detail, brief. I mean, show interface, serial interface.
Which router? Router
zero.
2?
Router 2.
Okay.
You said clock rate before, right? One side only. Yeah, clock rate. Clock rate is the actual bandwidth, right?
Yeah, I said the clock rate. We can see, right?
Go there. Go serial router 3. Serial interface 010.
Okay.
So see the interface. Clock rate is 20,000, sir. You need to set it.
20,000. We are not using this interface.
Okay, so set for that one also.
It is not connected, Malice. Why you are setting the clock rate?
No. What I am saying is interface serial 010 is connected with another router with clock rate set to 64,000, right?
This is router 3.
No, leave that one, sir. I am talking about interface serial 010. We give IP address 2, right?
Yes.
So give clock rate for the same as that one, another side.
Clock rate will be given only one side, not both the sides.
But we didn't use the.
Okay.
There is
okay, I'll give the clock rate if you want. It will not accept. Let me show you that.
No, it will accept because there is two types of serial interface. We use the normal one with
clock rate
clock rate.
64,000. Okay, see, not accept. Yes. This command is applicable only for DCE interface. If you want, I can do the shutdown and say no shutdown. Do show IP interface. Do show IP route. Still
okay.
Not, yeah.
Can you show interface brief? Serial interface 010 brief.
Show IP interface brief in router 3.
No. Show IP. Show interface. Serial interface 010. Show
interface serial
0/1 0.
Yeah.
Let's see the.
Is the correct IP address?
Yes, correct.
It's correct. MTU 500 bandwidth is this, delay, reliability.
I think the problem is with these two. When we set the clock rate, we need to use the serial interface connectivity with the watch sign inside the.
See, in this middle router, show IP route. Okay, he has learned, right? IA. What is IA? OSPF IA means what?
From another area.
Inter area. IA means inter area. Means it has learned from OSPF other area.
Yes.
Other area, right? He has learned. Okay, if you check the configuration for the OSPF, what we have configured, okay, we have in router 2 network is configured. Okay, all are belongs to the area 0. Okay, let's check the R1 now.
Sir, from this side, we didn't set clock rate. From router 1 side, We didn't
Router
say
1. We configured. 72,000 we configured. Let's change this. If you want, I will change that. No problem. 72, because for your satisfaction, I will configure. Say interface, serial
no
is
problem.
okay. Clock rate, I'll give 64,000. Okay, I'll say no share. Show IP route. See, this guy show IP route OSPF. He has learned 2 network. He has done the 2
You see? You see, sir?
Yeah.
Where are we? In router one, right?
Router 1, yeah.
So, okay, where is 2? Yeah, we learned 2. That's correct.
Then why this guy, router 3, show IP interface brief. What could be the problem, guys?
The problem.
Show run.
I don't know.
Let's remove the DSCP. So no IP DSCP pull. What is the DSCP they have configured? Yeah, this one. Copy and paste.
But mine is with DHCP. It works, sir. No problem with this, I think. Oh my God.
OSPF 10 only we have taken, right? Or 100?
10.
What did the blood show? Oh,
20, this also perfect, no problem with this. Who will solve this problem, guys? Clara, Angie, Andrew.
I don't know if we add loopbacks to router 3 because it is having no loopback, but at first it had copies of loopbacks from zit router 2. So let's try to add any loopback.
Loopback not required here. If you want, we can add it, but it doesn't make any sense because first he should learn the routes here. In router 3, show IP route. He has to leave. He has to learn the 2 network, 1 network, and 10 network. In this one, we should learn this all entire network should be available here. Check this is the correctly we configured, and router 1 also. See, this guy has learned, right? Show IP, show run.
10.
Same, no problem. 10. And here, there is a problem with only router 2.
Why?
Check what is the problem with router 2.
Yeah,
Show run. 2 network, 10 network, 20 network. That's it. Yeah. Is there any loopbacks? Okay, no loopbacks.
Yeah. Let's remove the OSPF on router 3. and redo it again. Maybe
You want me
that
to
will be-
you want me to remove this?
yeah, remove and again let's do this. Do it.
Okay. No router
OSP.
OSPF 10.
No.
Show IP interface B. Okay, this is 3 network, right?
Yes.
Okay, so let's configure once again. Okay, go to global configuration mode. Router OSPF 10. Okay,
Network.
I say network 192.168 3.0. I say wildcard mask 0.0.0.255. This is area 10, correct? Sorry, 20. Got it? This is area 20, right?
Yes.
The network, one more, 20.0.0.0, 0.255.255.255. And area,
0.
that's it.
Yeah.
Show IP route OSPF. It is loading something, can you see? Is it? Now it is coming, why? You can see, right? All it has learned.
Yeah.
Show IP route.
Nothing we change, but we do read. We do everything as it is, right?
Yeah, nothing, same configuration. Guys, remember, because as you know that it is not a real devices. This is a software-based packet tracer, Cisco packet tracer. Okay, sometime it will create the issue, but command everything what we did perfectly. We can see, right? IA means inter area, OSPF other area. Right? You can see show IP route OSPF. So he has learned 110 is the administrative distance. The one network that is from area 10. Okay, the cost he has calculated 129. So I hope I can able to ping from here in router 3 to 1, I think 1.1. Okay, I think 2.1 also I can ping. So let's check in R1 now. Show IP route OSPF. So now this guy also learned that is IA, means inter area. See, the cost is 129. Is same, right? The what cost we have got it that side. So here also same cost. Got it? So let's like show IP OSPF neighbor. Okay, the number for this guy is 13 network because loop back he has considered. In router 2, okay, we have created some loop backs, right? In router 2. And here in this router, there is a no loop back. We have not yet created any loop back. Or 2 loop back we have created. Because you will consider only the loop back as a neighbor. If you check in router 2, show IP route OSPF. He has done all the 3 network. If you type show IP route neighbor, show IP OSPF neighbor. So 3 and 16 is my neighbor. 16 loopback we have created in R1. Okay. And 3.1 is your R3 IP address. Okay. So there is one more command, show IP OSPF topology. I think interface, not border router. Who is a border router? You can see. So I is nothing but your intra area routes. Small I means he has learned from other area. Okay. Now how to check? Show IP. Show IP OSPF interface. Okay, the state is DR because it is a center router, right? See, the priority is same. Okay, let's check this guy. show IP interface, show IP OSPF interface. So this guy also DR, priority is 1. Okay, the cost is 1. And check this guy R1 now. Show IP OSPF interface. This guy also DR now. The router ID is 16. What is the router ID for this guy? Router ID is 3.1.1.1. And what about this router ID is 3.1.1.1. Then how do you check which is a DR and BDR? Let's say I want to make these guys a DR BDR. How do I can do that? Okay, router OSPF 10. Okay, let's say I think priority is not working here. Let's see router ID you can give. Already this guy is router ID. He has taken automatically, guys. Okay, IP OSPF, say, let's say router OSPF 10. So give the question mark. So passive interface, redistribution, router ID, network ID. This thing, because the election process is taken automatic because we have the only one router. I think priority command is not working here. I don't know. Neighbor. Okay, neighbor address means just to connect to the neighbor. I hope guys, because we are done with the multi-area. This is a multi-area. Same thing, we can connect a lot of areas. Like how many area you want to connect, we can able to connect it. We can connect one more area here. Okay, so if you want, I will send you this file. Okay, this is quite very interesting, important file, guys. Lot of work we did, right? This is our OSPF. OSPF multi-area. Multi-area text file, right? Okay, so I'll send you this both the files. Understood, guys? OSPF.
Victor.
Isaac or Isaka?
Saka.
Isaka.
Yes, same meaning.
Yeah. Understood, guys? Any questions? So that I can jump for next lab.
Yeah, I think these are things need practice.
Yes,
We
sir.
understand them as we practice.
Yeah, because you must practice every day. Until unless you just practice, okay, practice make you perfect, guys. Until unless you have done the practice, okay, so you can't understand. If you have any questions here, you can ask me, guys. No questions, can I jump for next lab?
Yes, sir.
Redistribution lab. Your next lab is redistribution lab. I think I have done one redistribution like let's say RIP to EHRP first lab. So this is the configurations what I did for the redistribution. Okay, so redistributions, how does it work, guys? Let me explain you that. See, the redistribution is scenario is one. Okay, say example, this is say your IBM company. Okay, and this is the HP. So this is your HP company. The scenario where you required. So both company, they are working in some new project. If they are working in new project, okay, maybe you are running here, say example, EIGRP in your organization, IBM people network. So they are running EIGRP. In HP network, okay, you are running RIP. In this scenario, okay, they will be having the SLA, service level agreement, for 365 days. So in this scenario, we need to do the redistribution of your network to IBM network, and IBM network, we have to do the redistribution from EIGRP to RIP and RIP to EIGRP. This is, we'll call it as your redistribution. Understood, guys?
Yes.
Okay, so can we do this lab? So let me show you this, how does it work, guys? Because we can see, let me make it big here. Now it is visible, right? The redistribution between RIP to EIGRP. Okay, so here the pink color network, okay, they are running the RIP. Blue color, they are running the EIGRP. Means this all network, 1, 2, 3, three network, they are running RIP. Okay, in one network, that is the two network, that is this WAN link and this LAN link. Blue color, which is come under this blue color, they are running the EIGRP. Okay, the redistribution should be done in the center router, which is connected the two different routing protocol. So means this is the main router. Okay, what they have configured with the redistribution. So let's say show IP route. We can see show IP route EIGRP. So he has learned the three network. Okay. So run. Let's see how they have configured. This is my last batch. I think previous batch they are configured. See, he has entered EIGRP 100, redistribute RIP, and we have to give all the metric value because RIP cannot understand the K values. That's the reason we are giving manually. Right? RIP cannot understand because EIGRP, it will calculate bandwidth and delay by default. Okay, the metric calculation of the EIGRP is based on your K values. Right? Bandwidth, delay, load, reliability, MTU. Right? We have to tell manually, we have to tell the RIP, please take this update. Okay, here also configured with the, again, go to RIP, okay, version 2, redistribute EIGRP 100, metric 3 by default. Metric 3 means, assume why it is 3, your RIP is going to work based on your hop count, number of hop count. Correct? Your RIP is going to work based on your number of hop count. That's the reason he has given 3. Because 3 routers we are using it, 3 hop count. Got it, guys?
Correct.
Can you do this lab right from scratch? Okay. Okay, so I think someone has pinged. I need to see. Go, sorry, who is this? MK Malice. Okay. So let's say I will do right from scratch, guys. So let's I will take the three routers here. So let me add the module. Just I'm giving the connection, guys. So I'll give access to one of the guys who is ready to give the IP address. Who is ready to accept my challenge, guys? I want you people to configure this lab. Who will configure? I want to see whether you are following my teaching or not. So this entire network you have to configure with RIP, and this network should configure with okay. Who will configure this? Clara, Angie, Andrew, Isaka. Even I will give the IP address for this. Nobody is ready to do. Everything I should do, when you will do, man, guys. Clara, can you do it? Can you help me out?
I'm using my phone, so I can't. My laptop just died and I don't have electricity.
Okay. Okay, who is ready to take this? Anybody? Andrew, Angie, Asma.
Starting from RIP to ERGP to OSP F.
No, next lab. After completing this, we'll do the lab. That one. Right now, we will do the redistribution between RIP to OSPF. Sorry, RIP to EHRP. And next lab will be OSPF to EHRP. Okay. So who will do this for me? Andrew, Isaac.
I'm not ready.
You are ready or you are not ready?
I'm not.
Then who? Isaac, Angie. I'll give the control. Edude, Eduda. Asma, can you do it? Assign the IP address fast, so that I will take one coffee and come back, if you don't mind. Nobody is ready to take. I don't know why. Why, guys? So I'll give control to Asma. I think she will do it. Asma, request, I'll give the access to you. Are you there? Assign the IP address for all the interfaces. Are you there, Asma? Andrew? Angie? Are you there, Angie?
I'm here, but I'm not ready.
Okay, who is ready? Just assign the IP address. If possible, you configure the RIP and EIGRP.
I'm not confident enough so that I can do.
How do you ask for what? For the access?
Who? No, I will make it host for you. Angie or who?
Okay.
Who is ready?
It's Angie.
Okay, Angie, I'll give you this access. Yeah. Yes. I think you can access from your side.
Okay. I'm not able
You're not able to?
to log into the router or anything.
Okay, let me check. Anki, just to, can you make it, make me host again?
Okay. You're now the host.
So, no, still I'm not the host.
You are from here. I can see you're the
Yes,
host.
yes, yes. Yes, yes. Let me check to control. I need to check this.
That's about this.
Hmm. I'm checking where to give the remote control in. I think a request for remote control. Yeah, so I'm checking that. Just give me 1 second, guys. So I'll be back. Okay, just allow water and come. Just I'm checking like where is this option, because I was using Teams, Microsoft Teams. So now I'm changing this. I need to check where is this option.
Okay.
Yeah, it is there somewhere. I think I forgot where is there. Okay, guys, some interruption here. Okay, I think remote control, I'll check it out rather than wasting the time here. So let's, I'll check this option later. Right now, I don't know where, yeah, I got it, man. So remote control to this thing. Anki. Anki, can you check now? Anki? You can, right? Can you hear me, right? Angi? Yeah. And don't use the tab key, because tab key, if you use, means it will go to different direction. Angi?
Okay. Yes, I can hear you.
Yeah, so please don't use the tab key. Okay. Press escape. I think they have removed, you have removed the color. Press escape, it will come. I just press enter somewhere here. Yeah. So now I think you can be able to open the router 1 and assign the IP address fast for me. Don't get scared, guys, because you people are learning.
I am double clicking the router, but it's not opening.
Yes.
Try to right click and then it will give you the list.
Yeah, I'm right clicking, but I'm not seeing anything. You can see my mouse moving, right?
Yes. You are moving the mouse. Yeah.
But when I do right click.
No, just click, not right click. Yeah.
One click, yes. Like
Yes.
At
Go.
least now.
Yeah, CLI. The power must be on.
Alone.
Yeah. And go to, yeah, on the power.
Oh, sorry. Used to maximize. Do I need to, is it on now? Because
let me 1 second. Yeah, now it is on. Let me check this is also on or not. Everything is out. Yeah, it's loading. I'll make it on and give it to you. Okay.
okay.
Yeah, so now we can go ahead. We can start configuring. Now, my computer is yours, Angie.
Okay. Why am I not typing? I'm using my.
Yeah.
Now I can see.
Means sitting in Malawi, you're doing lab from Malawi, Indian computer you're asking and doing practicing. You know why? Because of network, right? Because of network,
yes.
right?
Mm.
If there is no network, okay, we never communicate with you guys, right?
Mm.
So to give it a name, we should do host name.
Yes. You any name.
First name will be Angie.
I prefer Arawan. For easy identification, I prefer Arawan.
Yes. Okay.
So you can assist me.
Yes.
No.
Not only me, even you have friends, right?
Yeah, Clara, Andrew, Isaac, Maris, you can assist me.
Yeah.
Okay.
Even I'm also there. Even one more girl is there from Asma. She's from India, Bangalore. She'll also help you.
Asma also can help me.
Yeah, like there are many people are helping you guys. Out of 8 people are helping you.
That's very nice. So what's the next step?
As a go to interface and as an IP address.
Let's go to interface GI000.
Yeah.
Mm-hmm.
GI000 IP address.
Yes.
192.
168.1.1. Yes.
This is a slash 24.
Yes.
Sorry,
255.
255.0.
No shut.
Is it not shut down?
Yes.
Okay.
Okay. Go to the interface SE010.
It's a bit slow, maybe because I'm controlling from the other side.
I'll waiting you, madam. Don't worry.
So we should add the network or so this one is the IP address.
Yes,
Yeah.
at the address.
Just IP address.
Yeah.
IP address.
Sorry. IP address.
I know what are the lab you are doing. It is getting broadcast. You are doing the lab. It is broadcast in our YouTube channel.
Don't make her nervous.
.1.
Third one as well.
Yes.
See that
And
it is there on the screen. Angie, see on the screen the IP address is mentioned already.
yes, I can see. Help me with
Okay.
subnet mask
This one is
4/28.
255.0.0.0.
And see, Clara is helping you.
So
We
nice.
need to set the clock, right?
Okay.
Yeah. Yes, we
This
should.
one we should set the clock before we shut it down. We do no shut.
Yes.
Yes, set the clock rate.
Sorry. Like that?
Yeah.
Where is the
You need to write clock rate in the
one word?
exclamation mark.
Can you come again?
Yeah, you can just put a question mark so you can see the rates that we can add and we can choose one.
Okay.
Let's choose the 56,000 that we've been using, or 64,000, one of those.
Okay, I'll do 64. That's so many zeros.
Yeah, no shut. Awesome. Okay, you can exit and then we can go to the next one.
Second router.
No.
I didn't get you.
The first router you're done, you just go to another router.
Okay.
Congrats,
I can
Angie.
just
Put down. Put
let me
in and then.
minimize so I can be able to see.
Oh, okay, okay. Press N and enter.
I'm typing, but it's not coming.
Oh, okay. So
Yeah,
there
now
are
it
some
is.
things.
Yeah.
Okay.
R2.
Also go to interface.
You
You can start with the gigabits. The SE011.
Zero. Let's start with SE010. So we can go from left to right. Okay, the IP address is 10.1.1.2. Oh, wait. Is this supposed to
Okay.
be slash 2028?
Two, the two.
It
This
should
is
be slash
28.
8.
Okay, then we have to go back and change the
From
the
router
mask.
1.
Yes.
But I think from that class, that should be /8, not 28. Let's consider it to be /8.
Should we?
Yes.
Well, okay, yeah, maybe it was just an editing issue.
I think with this class, it is supposed to be /8, not 28.
Okay. So look what I'm doing. Like that? There's so
You have
many
put too many
zeros.
zeros. Yeah.
It's because when I'm writing, I don't see it
the
coming.
delay, yeah.
That's why.
Yeah, go to the other interface.
Just
Oh,
go
no,
up.
shut. Remember to bring it up just to no shut and then we can go. Hey, that link is up now.
Yeah, it is even up from the YouTube.
Okay, let's go to the next interface.
I'm excited. What have I done now?
Can you
Let
just
me
turn to
maximize.
let's see.
The
Okay.
screen is just so small,
Yeah.
so you will understand me going back and forth. But I'm excited.
Okay.
I'm on YouTube.
Interface is C011.
And
IP address.
20.
Yeah, 20.1.1.9. Oh,
Sorry, 201. 20.1.1.1. 255. 1, 2. Should I set the clock as well?
yes.
64. 1, 2, 3.
No shots. Okay. Interface GI000.
Okay. I want to see this IP. Oh, where is my work?
Click on the route again.
Again. Once, yes.
Okay.
Okay.
I didn't memorize.
192.68.
168.
But 2.1.
That is slash 24.
Yes, so 255, 255. Absolutely. Okay.
What? So we are done with this one.
Yeah, then go to the next one. Konosia. Sorry.
Yes, I'm on YouTube. R3, so interface SE 010. Like that?
Yes.
We need to set a clock or
No, it was set from that other side, I think.
okay, so I'm going for gigabit 000. Maximize and see. It's coming.
Mama, daddy.
I think I'm done. Have I left something else?
Job.
You did a good job. Now you're just going to rip.
Thank you. So we will start from here or we should go to router 1?
I think router 1, we should rip router 1, then router 3 will do the EIG, whatever that is there.
Correct. Anki, congratulations again.
Thank you, but you're all assisting.
You have the confidence to start.
At least it's coming. Okay, from here, assist me.
You need to define the rip.
So assist me how to do it.
Router. RIP.
Okay. And then enter.
Yes.
Please
You
direct
are
me.
into router 1.
Yes, I'm in router 1.
Okay,
Fine.
router RIP. And then you start adding the network. So in router 1, you add network.
Typing error and
Net.
Yeah, I've seen. So
Network
192.168.
168.1.0.
.0.
Yes.
You can see it now, it's .0. This one we use what? You say what?
Yep,
Wildcard mask.
you might as well leave it like that.
Ah,
But
okay.
you use the word, but yeah. And then at the other network, yeah, 10.0.0.
Sorry, Clara, why we didn't put wildly net mask?
Wildcard mask.
Wildcard mask.
Wildcard mask can be done only for the OSPF and GRP. In RIP, not required.
Okay, sure.
And please configure RIP version 2. Angie,
Yes.
RIP version 2 we have to configure here. No problem. We can after this also we can use the command. No problem.
Okay, 1, 2, 3, 4.
Yeah.
Enter.
I have entered.
Exit.
Okay.
Bear with me, I'm controlling from where? India. Uh-oh. What have I done? Okay.
Are we on ARA2 now?
Yes, I'm on R2. I'm clicking enter, but it's taking a bit of time.
The 10.0, okay.
Okay. That's 2, right? The 168 one.
Yeah. 2.0 and then the 10.10 one. 10.0 rather. 10.0.0.0 and then there is
20.
right.
Good.
Oh, typing error.
Wait, do we have RIP on router 3 as well?
No.
So, okay.
Just
So
so how to remove that?
you have to be in global config, right? Do exit. No router RIP. Okay, do router EIGRP.
From number 3?
Yes.
So do route 1.
No. Right.
EIGR router
Route.
EI.
You start with route.
EIG.
Yeah.
IG.
Please, and then you can choose an ASN.
Wait, I want to see if okay.
Angi, that is a router, ROUTER.
You miss.
Yeah, but the short form is okay. It was still right. It will still get the command, but it's router EIGRP. That's the command.
Got it, arouse the shortcuts.
It should be,
Yeah.
it should be router.
It has to have an ASN, right? We need to.
Yeah.
So router here, let's choose 100, just like in our example.
Why am I seeing you?
You have changed the meeting focus, so we can't see the video.
1 second.
The sharing screen.
Yes, the shared screen can't be seen.
Okay. Because just I'm doing some setting here. Okay. Now, can you check now? Can you check now?
So we haven't seen it yet.
Can you see now?
It's
Yes.
coming.
Yes.
Yeah, it is back.
It is back, right? Yeah. I don't know what is this focus mode. I don't know why this. What is the function of this option?
Okay, so do again router EIGRP, or just use the up arrow and then we'll add 100.
Yeah. So I think you are in router 3 now. You want me to? You will do, or can I give option? Give control to you again back.
Okay, because I can't see, can't do anything.
Okay, let me configure this right now. You're in router. Okay, router T. Okay, router EHRP 10. Okay, network. So which network? So 192.168 3.0. Okay, if you want to give the wildcard mask, we can give the wildcard mask 0.0.0.255.
Yes.
Okay, and one more is 20.0. Okay, 0.255.255.255. Okay, that's it. Okay, show IP route. Okay, still has not yet learned any network yet. Okay, let me check what did you configure here. Okay, show IP route. Okay, so you're configured with this network. Okay, fine, no problem. So it's working fine. 2 network has learned, right?
Yes.
20 network and 2 network has learned. Okay, let's check for center router. Show IP route. Okay, so 1 network he has learned. You can see, right? He has learned R. R means 1 network. Okay, in the middle router, we are going to configure the redistribution lab. Okay, so how to configure redistribution? So go to global configuration mode. Okay. Let me check what things you configured. Show run. You configured RIP.
Yes.
Right. So now I'm going to configure so where is EHRP are not configured? Why you configure 20 in RIP? So 20 network is EHRP.
Oh, okay.
Right. So we have to remove that. Okay, router RIP, no 20 network.
No network 20.0.0. Yeah.
Okay, so then I will go RIP, redistribute. Okay, what you want to redistribute? I want to redistribute, okay, RIP into EAGRP. Okay, that is EAGRP 10, right? I have given there in router 3. Okay, so EAGRP 10, so metric. So metric is asking what is a metric. So right now we are using 3 router, you know, right? We have to tell them, we have to give the metric values. Let's say I'll give 3 because 3 hop count, 3 routers we are using, right? Okay, or else we can give transparent also. Let it take automatically. Okay, then exit. Okay, router EAGRP 10 network 20.0.0.0. Right? Now we can see adjacency is forming. Right now I have to do the redistribution RIP. Okay, metric. So metric, what I should do? He is asking bandwidth. Listen here, guys. This is very important. He's asking the bandwidth because you know, okay, EAGRP cannot, RIP cannot understand this all K values. We have to tell manually. Okay, so bandwidth I will give, say example 20,000. Okay, EAGRP delay, I'll say example 2,000. All K values we need to enter. Reliability, right? So reliability I'll give 255. I must have very good reliability. Load, okay, where 255 is 100%. This also I'll give 255. Okay, MTU, maximum transmission I'll give 1500. That's it. Redistribution. Show IP route. We can see he has learned 3 network now. Can you see? Show IP route EAGRP. 3 network he has learned, right? And same thing if you check here. So 2 network, 20 network has learned. 2 network has learned. Now let's check this guy. Show IP route. So did you notice here? What does that EX indicate? 10 network has learned. Okay, 1 network and 2 network. What does it DEX means? DEX means what? EAGRP external routes. Got it?
What does that mean?
External route means here is learning, you are running the EAGRP, right? Here you are running EAGRP. And here you are running RIP. Correct?
Yeah.
When you're done the redistribution, okay, the EAGRP, this all the update he has learned by using the redistribution, but it will accept in the terms of your EAGRP only.
Okay.
If you check here, okay, external EAGRP. Okay, what is external EAGRP? These 2 are external, right, for him. These 2 are external for him. Got it? So now I can able to ping from here. Ping 192.168.1.1. So repeat hop count, say example 5. Datagram, say 6.
Sir, is it possible we can run that redistribute RIP metric on router 1?
Sorry?
Is it possible we can run that command, redistribute RIP metric on router 1 or router 3?
No, it's not possible because you know it is not connected. Why you want to do the redistribution here?
Okay.
The router which is connected, one side EAGRP, one side RIP.
Okay.
Here we have to give. Here, okay, in this router, we have to do the redistribution. Okay, because this is the router which is connected RIP Okay,
And
here
the
you connected with the EIGRP.
Sure, thank you.
Okay, we have to redistribute this side to this and this side to this. And when you've done the redistribution here, it doesn't make any sense. What you want to redistribute, because it's running EIGRP, there is a no EIGRP configure any one of the link. This is the WAN link, right? Okay, this is your LAN. Okay, what you want to do the redistribution here?
I got you. Thank you.
Yeah. I hope guys you understood this lab, redistribution lab.
Yes.
Okay, so let me save this. Okay, and this is redistribution lab. Redistribution RIP to EIGRP. Okay, I'll share this file, both the files. This is text file. So let me share this file. Redistribution lab. Yeah. Okay, I'm sharing these two files now. I hope you received it, right? Okay. So,
Yes.
okay. So please open this lab. Okay. So one more thing, because now it is almost all time up here. What we will do, guys? We shall continue next week. Okay. I also share you the other lab. Okay, which we had done previously with the other batch, so that we'll do from better to do from your side. That is EIGRP to OSPF, guys. Okay, so that lab also I'll share you, which is there on the screen. This is EIGRP to OSPF, guys. This lab also I'll share you. Okay, so let me share you this one as well. This lab I have not done for you, but you just try to do from yourself, guys. If you are unable to do it, we'll do it. This is the command. Okay, what I shared to you. Okay, so I have sent the redistribution between EIGRP to OSPF. I have shared you the command. I have shared you the topology with the lab file also. I think you can able to do it.
Thank you, sir. I just received it.
Okay, I think you have received it. Please download right now, because once I close the meeting, you can't able to download this. Okay, guys. So, guys, please tell me, because I don't know, many people are not joining, because I was expecting 60 people has been registered for this training. I don't know, my very less people has been joined. Hardly, I think 7 or 8 people. I don't know what is the reason. Maybe I think they're not interested to learn. I think they don't. I don't know what the reason. Okay. Next week we shall continue with other topic, guys. That is very important topic. That is ACL, access control list will do. And we will do the lab for access control list, standard, extended, named access list. That is your network security.
Thank you.
Have you shared the PowerPoint?
Yeah. I not shared. Let me share. Today's PowerPoint slide, I will share you. I think it is there in my inbox. Let me take that. Yeah. It's a 3.6 MB file. Okay, so I think you have received it. So download this PowerPoint slides. It is also there in my Google Drive. I think, let me share you that one also. Get the link. Guys, please tell me your email address. I'll share you from my Google Drive. Clara, can you tell me? CLE? Yeah, CLA.
You can start with Andrew. It is kashstand@gmail.com. It's KA.
KA. Go ahead.
CH.
CH. Okay, I'll do one thing, guys. I'll directly send from this this file itself. I will download. I will send you guys.
Thank you, sir.
Because it is there in my Google Drive, because it takes time to type all your email addresses. I will send you all these PPT files.
All right.
Okay. I hope,
Be
guys.
blessed.
Okay. Yeah.
I said be blessed.
Thank you, man. Thank you very much. I hope, guys, you are learning something. And maybe I think Angie is very bold girl, and she accepted my challenge. She has done very good lab. Of course, she has done slowly, but next time I think she will do fast.
Yeah, with practice more, I will catch up. And thanks to everyone who has assisted.
Yeah. I think this lab, today's class, I think you learned something, guys. OSPF lab we have done, right? It's very interesting lab. What about
Yes.
this one, Isaac, Andrew?
Yes.
Yeah, there is progress on what we've learned. I hope by the end of the day, we'll have something to celebrate on, because the knowledge that we're getting, I think some of us has never been there.
No. Thing is, guys, please, I don't know, many people are, because already 66-70% they have registered. I don't know, nobody is joining, because, you know, I also studied in the weekday batches for the free training, because even weekday also very less people join, around 4 to 5 people. Then I should stop for the weekdays. Then I planned for most of the people, they're asking for weekend batches. Then again I changed for Saturday, Sunday. Even Saturday, Sunday, I think 6 or 7 people now.
Sorry?
For Malawi, I think with this cyclone, maybe some have failed in the reasons of electricity and some displacements.
Anyway, let's see, because, you know, it takes another, I think, 3 weeks, guys. Still a lot of topics to be covered, guys. So it takes a lot of time to complete all the portions, guys. It takes a lot of time. I hope you are following me, guys, right? You're understanding my teaching, guys?
Yes.
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 No problem, right? You can able to understand my English, my teaching skills. Because, you know, yeah, go ahead.
Say we are able, but sometimes you are fast. So at least slow down a bit.
Okay. Thank you. I'll go slow. Thank you very much.
And sometimes it's better to have a brief on short term. Say like, for example, my first day when I had the word RIP, it's like rest in peace. But it was the repository information, what. So it's some keywords, you need to have a short brief on that keywords.
What kind of keywords?
For example, for the first time, what I heard about the word RIP, it was what happened with your RIP, and the RIP is a rest in peace, but it's not what it means. You mean the other words, different meaning.
Okay, understood, man.
Okay, sorry for that, sir.
Yeah, no issues. Because, you know, RIP usually net routing information protocol. I think I told you before, because whenever I start any protocol, first I will tell the long form what RIP stands for. Then I will start.
Okay.
Yeah.